Hello everyone, today we will be discussing about product of two vectors. You have studied about the matrices multiplication, right? If you multiply any two matrices, again you will get another matrix, right? So here in the product of two vectors, there are two types of product is there. One is the scalar product or dot product. Second one is the vector or cross product, okay? Scalar product means you will get one value. Vector product means you will get vector. Okay, I think you might have studied this one in the physics, scalar and vector product. Now we will see what is a scalar product. Okay, let us consider, simple it is. If I consider one vector, this is the A vector. Okay, another vector is, this is B vector. A vector and B vector, two vectors, and which makes an angle between them will be theta. Okay, then the dot product of A vector dot B vector or scalar product is defined as A vector dot B vector is equal to magnitude of A vector into magnitude of B vector into cos theta. Is it clear? A vector dot B vector is equal to magnitude of A vector, magnitude of B vector into cos theta. But while finding the dot product, we will not use this formula. Directly we can find the scalar product. But to find the angle, to find the cos theta, we need to use this formula. Okay, remember this one. Now one more thing, see here you can see this A vector dot B vector is always a real number and it is a scalar, right? Magnitude of A vector will be a real number, this is real number, and here cos theta is also an angle, you will get one real number. So A vector dot B vector is always a real number and it is a scalar. Dot product of any two vectors, it gives you a scalar. That is the first thing. Second thing is, if it is any two vectors, A vector and B vector are perpendicular each other. Clear? If it is any vectors, if I consider these two vectors, A vector is perpendicular to B vector, then obviously the angle between those two vectors will be, that is theta will be 90 degree, right? If any two vectors are perpendicular each other, then the angle between them will be 90 degree. So theta is equal to 90 degree. Now dot product of that is A vector dot B vector is equal to, see, magnitude of A vector, magnitude of B vector into cos 90. The angle cos 90 will be equal to 0. So A vector dot B vector will be equal to 0. So this is an important one. A vector dot B vector is equal to 0 implies either either A vector should be 0 or B vector should be 0 or angle should be theta is equal to 90 degree. So what we can say is A vector dot B vector is equal to 0 if and only if, okay, this is true in the both the direction. A vector, this is equal to 0 if and only if A vector is perpendicular to B vector. Clear? A vector dot B vector is equal to 0 if and only if A vector is perpendicular to B vector. This is the one thing. If it is the angle between them is 0, A vector and B vector both are same. So if it is angle theta is equal to 0, then the dot product, that is A vector dot B vector will be equal to magnitude of A vector into magnitude of B vector, right? Since angle theta is equal to 0, cos 0 will be 1. So A vector dot B vector will be equal to magnitude of A vector into magnitude of B vector, or we can, in particular case, we can write A vector dot A vector, because both will be same, is equal to magnitude of A vector into magnitude of A vector. So this is equal to magnitude of A vector square. Clear? So this is the one important one and this is the second one. And one more thing, here the angle should be between 0 less than or equal to theta less than or equal to 180 degree. Okay, the angle between them is between 0 to 180 degree. If it is angle theta is equal to 180 degree, now angle between two vectors, like this, A vector this one and B vector will be this one. So angle between them will be 180 degree. Then cos 180 is equal to minus 1. So this will be A vector dot B vector will be equal to magnitude of A vector into magnitude of B vector, and cos 180 is equal to minus 1. So what we can write, A vector dot B vector is equal to minus magnitude of A vector into magnitude of B vector. This is the second thing. One more important one. See, if I write dot product of I cap dot I cap will be equal to, can you say, or J cap dot J cap, K cap dot K cap will be equal to, see, you know this one. See, if I consider vectors, axis, so this is the x-axis, y-axis and z-axis, right? This is a unit vector I cap and this is j cap and this will be k cap. You know that all the three axes are perpendicular each other, right? So if I consider I cap dot I cap, the angle between them will be 0, right? I cap dot I cap. So here you can see this one. Directly you can write I cap dot I cap will be magnitude of I cap into magnitude of I cap. I cap means it is a unit vector, right? Magnitude will be equal to 1 and here cos 0 will be equal to 1. So I cap dot I cap will be, or everything will be equal to 1. Is it clear? Remember, I cap dot I cap. With that only, dot product of that itself always equal to 1. J cap with J cap is equal to 1 and K cap dot K cap is also equal to 1. If I consider I cap dot product with J cap, can you say I cap and J cap? This is I cap and this is J cap. As I told you, these two are perpendicular each other, right? So perpendicular each other means angle between them will be 90 degrees. So cos 90 will be equal to 0. So I cap dot J cap will be equal to 0. Is it clear? And similarly, J cap dot K cap is also equal to 0 and another one is K cap dot I cap is also equal to 0. So this is the important one. If it is a dot product of itself will be equal to always 1. Dot product of one unit vector with another will be equal to 0. I cap dot J cap is equal to J cap dot K cap, that equal to K cap dot I cap always equal to 0. Remember this. And one more thing is angle. Here to find the angle between the two vectors, any two vectors, we'll use the formula cos theta is equal to, by using this formula we can write A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So this is to find the angle between any two vectors. Important formula. Okay, based on this formula, the problems are there. Those are important for 2 marks. Now we'll see properties of a scalar product. Simple. See first one, commutative law, that is A vector dot B vector is always equal to B vector dot A vector. Remember, if it is 3 vectors are there, let us consider A vector, B vector and C vector. So A vector dot B vector plus C vector. You know the vector addition, right? We have to add the corresponding terms, will be equal to A vector dot B vector, okay? A vector dot B vector plus, like distributive law, A vector dot C vector, okay? Next one, if it is lambda is any scalar, then lambda into A vector dot B vector can be written as lambda A vector dot B vector, or we can write A vector dot lambda B vector, or you can write this as A vector dot B vector into lambda. Simple it is. If you find the first, you can find the scalar product, then you can multiply with lambda, or first you can multiply lambda with A vector, then you can find the scalar product with B vector. Here first you can multiply with the lambda with the B vector, then you can find the scalar product with A vector. So if you do anything, this will be, all the values will be same. Okay, you can multiply lambda first or lambda to this one, like product only. Clear? So this is about that. Now we'll see how to find a scalar product without using that formula. Actual formula is A vector dot B vector is equal to magnitude of A vector, right? Magnitude of B vector into cos theta, where theta is the angle between two vectors, A vector and B vector. I will say first I will consider A vector is equal to A1 I cap plus A2 j cap plus A3 k cap. So this is the first vector. We will consider the second vector as B vector is equal to B1 I cap plus B2 j cap plus B3 k cap. These two vectors we have considered. Now we have to find the dot product. It will be A vector dot B vector is equal to, we substitute that A1 I cap plus A2 j cap, right, plus A3 k cap dot B vector is, write that B1 I cap plus B2 j cap plus B3 k cap. Now we have to multiply each and every term. I mean A1 I cap to this one, then plus A2 j cap with this one, plus A3 k cap with this one. So that will be, now see, A1 I cap dot product with, what is that, B1 I cap plus B2 j cap plus B3 k cap plus then A2 j cap dot product with B1 I cap plus B2 j cap plus B3 k cap. See here, these dots are very important, okay, write it properly, plus next one is A3 j cap, right, A3, sorry it is not there, j cap into, sorry, not into, it is a dot product, A3 j cap in, yeah, B1 I cap plus B2 j cap plus B3 k cap. Now we need to multiply this. See here, A1 I cap dot B1 I cap. So here A1 and B1 are two scalars, right? Those are the values, and I cap are those are the unit vectors. So we can write this one as, first we will write the scalars A1 B1 I cap dot I cap. It's clear? Dot product with the two vectors. I cap dot I cap plus second will be A1 B2 remaining I cap dot j cap, right, plus next will be A1 B3. First write the scalars A1 B3 I cap dot k cap plus second term here A2 j cap dot B1 I cap. So we can write A2 B1 then j cap dot I cap, right, plus next will be A2 B3 j cap dot j cap plus next will be A2 B3 j cap dot k cap. Last one more term is there. We'll multiply that. So that will be A3 B1 j cap dot I cap plus A3 B2 j cap, sorry, I j and this should be k, right? Sorry, A3 k cap. See here A3 k cap. So here also A3 B1 k cap, right? See A3 B1 k cap I cap. So this will be A3 B2. So this will be now k cap. I hope you understood this one, right? So this should be k, not j. Last term will be plus A3 B3 k cap k cap. Now can you see the answer? See, what is the dot product of I cap dot I cap? Dot product of this one. Angle between them will be 0, right? So I cap dot I cap will be always equal to what? Remember, I cap or j cap or k cap will be equal to 1. If it is I with j or k, then the angle between them will be 90 degree. So that will be equal to 0. So here this will be equal to 1, right? So I can write this as A1 B1 plus, see I and j is there, different unit vectors are there. So this will be equal to 0. Then I and k is there. So this is also equal to 0, right? Next it is j and I. So again this is equal to 0. Now here A2 and B3 is there. So j and j cap dot j cap will be equal to 1. So that is A2 B3. Now here j and k. So it will be 0. Here k and I, again it is equal to 0. K and j, this is also equal to 0. Here k and k is there, so this is equal to 1. So plus a3 b3. So to find the scalar product, what you have to do, just multiply the corresponding terms, that is a1 b1 plus a2 b2 plus a3 b3. So it will gives you a scalar product of any two vectors. Remember this. Now we'll see projection of a vector on a line. Okay, important one, important for 2 marks problem based on this. Let us see what is meant by projection. Projection is nothing but it's an image. So if I consider a vector AB vector, okay, this is the one vector and this makes an angle theta. Okay, this line vector is makes an angle theta with the directed line L. Directed line L. For example, see, if I consider this is the one directed line L, okay, and here this is the vector A2B. A2B is a vector which makes an angle theta in the anti-clockwise direction. Then the anti-clockwise direction. Is it clear? AB is the one vector. Will represent this as A vector. AB vector is a vector which makes an angle theta with a directed line L. Then the projection of AB vector on line L. I mean projection of AB vector is nothing but image of AB vector. So if I draw perpendicular from here to here, it's clear? So this is the one considered as point C. Now here AC vector is called the projection. AC vector is called the projection of a vector AB on the line L. So usually we represent projection by P vector. Clear? The project first, the one vector is there, AB vector, which makes an angle theta with the anti-clock direction, okay, in the directed line L. Then the projection of AB vector on a line L is AC vector, or we can say, simply we can say that as P vector. So here AC vector or P vector is called the projection of a vector AB on a directed line. That should be a directed line on L. Okay. Now can you say what is the magnitude of P vector? Magnitude of P vector will be equal to, see, this is theta and here you can observe this is 90 degree. By using this I can define cos theta, right? So cos theta will be equal to adjacent by hypotenuse. Adjacent here, I mean length we have to consider. This is a P vector. So length means magnitude of P vector, right? Magnitude of P vector divided by here hypotenuse is A vector. Length of this will be magnitude of A vector. By using this we can write magnitude of P vector is equal to magnitude of A vector into cos theta. So this is the length of the P vector. Is it clear? So this is the length of, I mean magnitude of P vector. Now how to find P vector? This will gives you a value, right? Magnitude is nothing but it's a value. Now how to find P vector? To find P vector or AC vector, you need to multiply this with a unit vector of this P vector. Is it clear? See here, listen carefully. Magnitude of P vector will be equal to magnitude of A vector into cos theta. So it will gives you a length of P vector. But to find the vector P, you have to multiply this with the unit vector of P cap. So that will be now, see, magnitude of A vector cos theta into unit vector of P vector, that will be now P cap. Clear? So this will gives you the vector. So here you can observe this, the angle is 0 less than or equal to theta less than or equal to 90. Right? So this is a AB vector and AC vector is here. Now if it is angle is in the second column, let us consider somewhere this is A, okay, and this is B. Now this is a vector AB. Now angle is more than 90. So to get the projection, I have to draw perpendicular from here to here, right? So this will be now AC. So this is AC, okay. Then the angle is, I mean the vector, direction of the AC is depend on the angle theta. Here also projection will be AC vector, or we can write this as P vector. If it is in the third quadrant, here, see, if it is, this is in the third quadrant. So this is the point A and this is point B. So this is the AB vector. Here you can see this angle is more than 90. It is between, right, 180 to 70. Now this will be, here I have to draw one perpendicular. So this will be C. Is it clear? AB vector which make projection of AB vector. Projection of AB vector on a directed line L will be AC vector, or we can write this as P vector. If it is in the fourth quadrant, see here I can see this as A and here somewhere B is there. So this is the line and here this is the angle more than 270. It is in the fourth quadrant. Now what I have to do? I have to draw a perpendicular from here to here. So this will be C. Now projection of a vector AB on a line L is given by AC vector. This is in this direction. AC vector. So this will be now P vector. See here A to C and here A to C in this direction. Here you can observe this is A to C. Is it clear? So one more is there. This will be A to C. This is about the projection. Here we will see some formulas. Those formulas are important to solve the problems. Okay. Let us consider. Let P cap. Okay. We have considered P vector. So here P cap means it is a unit vector. I mean magnitude of this will be equal to 1. Let P cap is a unit vector. Unit vector along L. Along L. Then the projection of, important one, then the projection of a vector, projection of a vector A, projection of a vector A on the line N, on the line L is given by, as I explained this one, is given by A vector dot P cap. Is it clear? To find a vector, we need to multiply by P cap. That will be A vector dot P cap. So this is an important one. If it is P cap is a unit vector, then projection of a vector A vector on a line L is given by A vector dot P cap. Now, if it is two vectors, I mean if the projection of, this is also important one, projection of a vector A on the line, on the vector, sorry, on the vector or line, on the vector B vector. Now here we have considered the line as P vector, right? P cap. Here projection of a vector A vector on the line B vector is given by, similar to this, see, A vector dot in the place of P cap, in the place of P, here we have B, right? Here vector is P, but here we have considered the vector as B, so it is given by P cap. So this is equal to A vector. What is the unit vector of B cap? B cap can be represented by B vector, right? Dot magnitude of P vector, right? B unit vector of this is equal to this as it is A vector dot B cap is B vector divided by magnitude of B vector. So simply we can write this as A vector dot B vector divided by magnitude of B vector. So this is the important formula to find the projection of a vector on any line. Okay, remember this. Now if it is, one more thing, if it is an angle theta is equal to 0. Now what we can write, see I have written the formula there. P vector is equal to magnitude of AB vector, right, into cos theta. This is the magnitude of P vector. In the previous we have written that, right? Magnitude of P vector is equal to magnitude of AB vector into cos theta. If it is angle is equal to 0, I mean this will be cos 0 is equal to 1. So magnitude of P vector is equal to magnitude of AB vector. Now what we can say, the projection of AB vector is AB vector itself. The projection of AB vector will be AB vector itself. Is it clear? Now, if it is the angle theta is equal to 180 degree, if it is the angle theta is equal to 180 degree, now magnitude of P vector is equal to magnitude of AB vector into cos 180. What is cos 180? It will be minus 1, right? So this is minus 1. So what we can write? Magnitude of P vector is equal to minus magnitude of AB vector. By this, see P vector, magnitude of P vector is equal to negative of that. That means magnitude will be same. only negative means the direction will be different, right? Whenever two vector, negative of vector means the magnitude of two vectors will be same, but the direction will be opposite. So in this condition, what we can say is projection of AB vector is BA vector. Is it clear? If it is angle, remember this, if it is angle theta is equal to 0, then the projection of one vector will be same. If it is theta is equal to 180 degree, then the projection of that will be, magnitude will be same, but the direction will be opposite. So AB vector is there means the projection will be BA vector. Suppose if it is BC vector is there, okay, and the angle is 180 degree, then projection of BC vector will be CB vector, or I can write minus BC vector, or we can write that as CB vector. This is about the projection. Now we will solve some problems based on this, important for 1 mark. But I forgot to say one thing. See, if it is angle theta is equal to 0, then the projection of any line will be same, right? If it is theta is equal to 180 degree, then the projection of that will be, the magnitude will be same, but the direction will be opposite. If it is AB vector is there, then the projection of this vector will be BA vector. Projection of this AB vector will be BA vector. If it is theta is equal to 90 degree, now can you say theta is equal to 90 degree? So this will be a directed line, yes, and here this is the vector. This is AB vector, right? Now I have to draw perpendicular from here to here. It is not possible, right? So because since the angle is 90 degree, so 90 degree means cos 90 will be equal to 0. So projection of AB vector, remember projection of AB vector, if it is angle is theta is equal to 0, theta is 90, then the projection will be 0. Because here we cannot find any image of this line. Is it clear? If it is theta is 0, then that itself. If it is 180 degree, then negative. If it is 90 degree, then the projection will be 0, because it is not possible to find the image of this AB vector on this line. Okay. Now we will see this problem. Find the angle between two vectors A vector and B vector with magnitude 1 and 2. So magnitude of A vector is given as 1 and magnitude of B vector is given as 2. Right? And the thing is given this. Now what is the formula? You know, A vector dot B vector is equal to magnitude of A vector, magnitude of B vector into cos theta. What is cos theta? We can write this as A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Now A vector dot B vector, what is the value? It is given as 1. So this is 1 divided by A vector is 1, B vector is 2. 1 into 2 will be 2. So cos theta is equal to 2. So theta will be equal to cos inverse of 1 by 2. Right? Cos inverse of 1 by 2 means it is pi by 3. So angle between these two vectors will be 60 degree. Okay. Look at these problems. Both are important. Okay. See here, if A vector is given and B vector is also given, you have to show that A vector plus B vector and A vector minus B vector is perpendicular. When two vectors are perpendicular, perpendicular means their angle between these vector and this vector will be 90 degree. If it is the scalar product of these two vectors is equal to 0, right? If it is theta is equal to 0 means cos 90 will be equal to 0. So scalar product of these two vectors is equal to 0. Then we can say that these two vectors are perpendicular, right? So first we will find A vector plus B vector, then we will find A vector minus B vector, then you have to find the scalar vector of those two vectors, so that we can prove that it is a perpendicular. First let me write A vector plus B vector. Okay, directly we will find this A vector plus B vector. 5 plus 1 will be 6 I cap, and plus here minus 1 and plus 3. So it will be plus 2 j cap, right? Addition or subtraction means you have to subtract and add the corresponding elements, right? So this is minus 3 and minus 5 will be minus 8 k cap. That is A vector plus B vector. Similarly we will find A vector minus B vector. So we need to subtract 5 minus 1 will be 4 I cap, right? Minus 1 minus 3 will be minus 4 j cap, minus 4 j cap. Last one minus 3 and plus 5. Minus of minus will be plus 5. So it is plus 2k cap. Right? Now we will find the dot product of this. A vector plus B vector dot. See, this is very important. You have to represent dot A vector minus B vector. So to find that, what you have to do? A1 into B1 plus A2 B2 plus A3 B3. Right? So we will multiply 6 into 4. It will be 24 minus 4 into 2 will be 8 minus 8 into 2 will be 16, right? See, 6, 4, 24 plus 2 into minus 4 will be minus 8 plus minus 8 into 2 will be minus 16. So, minus 8 minus 16 will be minus 24 plus 24 and minus 24 will get cancelled. So, this will be equal to 0. So, two vectors are perpendicular each other. Dot product of A vector plus B vector dot A vector minus B vector is equal to 0. So, we proved this one. Let us move to this problem. See. Find the important one, projection of the vector. You have to find the projection of this vector A vector on the vector B. You are finding the projection of a vector A vector on B vector. Okay. What will be the projection formula? Have studied this. That will be A vector dot B vector, right? Divided by, is it clear? Magnitude of B vector. Yes, I hope you remember A vector dot B cap, right? So this will be now A vector dot B cap is mod of B vector divided by mod of B vector or magnitude of B vector. So we can write A vector dot B vector divided by magnitude of B vector. So that we write this formula. Now we will find the dot product of those. A vector dot B vector is equal to, what is that? See here, what it is here. 2 into 1, 2 plus 3 into 2 will be 6 plus 2 into 1 will be 2. So total it is 10, right? 8, 10. So this is the, now magnitude of B vector is equal to root of, yes, 1 square 1 plus 2 square will be 4 plus 1. So it is equal to root 6. So the projection of a, therefore projection of a, finally you have to write vector, projection of a vector A on a vector B is given by, substitute this, A vector dot B vector will be 10 divided by root 6. So this is the final answer. In the previous problem, while finding a vector plus B vector, better you write A vector first, then plus B vector, then add. Okay, directly don't do that because it is a 2 marks problem. Steps are important. But you substitute this and similarly A vector minus B vector, then you subtract this. Okay. See this problem. Find magnitude of A vector minus B vector if two vectors A vector and B vector such that magnitude of A vector is given as 2 and magnitude of B vector is 3 and A vector dot B vector is equal to 4. Now we will find this. See, I will write magnitude of A vector minus B vector whole square. Okay. This can be done as A vector minus B vector into A vector minus B vector. Right? So sorry, dot. Is it clear? Dot product of A vector minus B vector dot A vector minus B vector. Now we will multiply. This is equal to A vector dot A vector, right? A vector into B vector. So it will be minus A vector dot B vector. See, your dots are very important. Minus, this is B vector dot A vector. B vector dot A vector. This is minus into minus will be plus B vector dot B vector. Right? See here, this I can write magnitude of A vector dot A vector will be magnitude of A vector square minus, see here, A vector dot B vector will be equal to B vector dot A vector, right? Because this is vectors dot product will be commutative. So B vector dot A vector is equal to A vector dot B vector. So we can write this as minus 2 A vector dot B vector plus magnitude of B vector square. B vector dot B vector. So this is equal to magnitude of A vector is given as 2. So 2 square will be 4 minus 2 into A vector dot given B vector is 4. So into 4 plus b vector is given 3. So 3 square will be 9. So this is 9 minus 8 will be 1. 1 plus 4 will be equal to 5. This is now magnitude of a vector minus b vector square. But we need magnitude of a vector minus b vector square on both sides. Take a root on both sides. So this will be equal to root 5.